Hi, I'm Bob Bender with CTS Telecom, and I've been attending NANOG since NANOG 52 in Denver, and we had been keeping stats on our network, and we have our S&MP monitor automatically gens reports for me, and we've been studying all of our traffic, recently, but then we figured out, well, we had data back to 2010. So what we did is we built it all and took a look at it, and I realized that it really was followed very closely a paper that was called "The Internet is Flat: Modeling the Transition from a Transit Hierarchy to a Peering Mesh." And I put this presentation together with Ahmad Damdira at CADA, and he unfortunately can't be here because he and his wife just had their second child, so he's very busy. But it really was important for us is joining NANOG and being from a smaller company, it really helped us to open us to a new world of ideas. And so I'd run into this paper, and of course, we'd always thought, well, for getting the internet, you're going to go to a tier 1 and you're going to get connections. And one of the things that was really driving us is we'd already been converting ourselves from a phone company into a last mile packet optical provider. And we had gig or GPON to our premise, but we only had two OC12s upstream, and it just was sort of a disconnect. And then the other problem that you had is the further out from the IX you are, the harder it was to get transport and the higher the price of the transit is. So we initially were motivated to try to get into the IX just to get access to market price transit. But we took a little side turn from there. This idea of originally we were just thinking, well, the internet is this backbone, and then this paper really opened our eyes to what was happening in the network itself. At that time, it really wasn't clear who the dominant content providers would be. There were a bunch of people competing for the social networking space. Streaming was just sort of emergent, but we just knew that, that it was key that, we start participating in looking at peering and getting content directly, because we were just seeing in our own data, already, the strength of certain content providers becoming more dominant just in our own NetFlow data. And so this paper was originally presented at ACM CONEXT in 2010. And I believe it was Ahmad's, the culmination of his doctoral work at Georgia Tech, and then Konstantin was his advisor, and it was really novel on what they had done. One of the problems of studying internet traffic is, first of all, there's a lot of it is obscured because it's proprietary. So the peering relationships, content delivery networks, content networks, a lot of that necessarily isn't visible, although there had been some earlier work that they had built on. The flattening internet topology, Gill et al., which was presented in 2008, used an automated trace route that started to document, the shortening of the paths to content as more and more content was moving into the IX, due to CDNs. And so their innovation they did is the ITER model was largely used for modeling in economic and social models. So it's an agent-driven computational model. And so what they did is they tried to take the internet and build a smaller model of it to look to outcomes, because it's constantly changing. It's very hard to predict exactly what's going to happen. So what they tried to do is they took, even with our own network, we are constantly removing or adding peering links because you're looking for, you're trying to optimize your cost or your profits, you're trying to optimize your traffic flows, and that's constantly changing. So there's a self-organization component to it all as well. So they used a model of 1,500 ASs, and it took into pricing, the interdomain links, geographic constraints, and and then using provider peer selection methods. And then the model ran until it reached equilibrium, at which point there was no reason for links to be changed. And so, they ran the two models, and then there's a great detail in the paper on their specific methodology. But the idea was you're trying to do what a provider would be doing on their own, but to do it with this agent-based model. And their work was, built heavily on the interdomain routing, internet interdomain traffic with Craig Leibovitz, the Arbor Group. It was presented at SIGCOMM in 10. And what they were really documenting was this, and then this slide is derived from their content, and again, the internet is flat was based on a lot of their work as well. And the idea was there was this transition point, and I tie it back to, if you look at the Cisco VNI, at the point at which media traffic exceeded web traffic. And so there's a point in somewhere 2006, 2007, 2008, at which media stream traffic at that point exceeded what the traffic was from traditional web-based, where it was going to be coming from origin. And then at that point, you started having this, dramatic content consolidation. And so they looked at the two different models, one based on the idea of a transit hierarchy with the tier ones at the top, and then tier twos, that were doing a combination of peering and transit, and then tier threes that were transit only. And then if you were, an enterprise or a content provider, everything would have to go through that backbone. And then there's this transition point at which, all the content, the paths got shorter and all the content went to the edge. So those are the two models that they had built. And the idea was, in their modeling, they ran the models until they reached equilibrium, and essentially were simulating what the internet looked like under a transit hierarchy versus the peering mesh. And so really it's about the volume of traffic flows, so that the peering links got much shorter, and the short links also had the majority of the traffic. And so that really is, especially as many small providers, were, really struggling to keep up with demand as streaming really took off. And then the other big prediction was, because of the changes of the delivery of the bulk of the traffic, that it made it very difficult for tier ones to be profitable, and so that would force consolidation was one of the predictions. And of course, I think that's been very true as you've watched various providers combine, and it's still ongoing. And so one of their things they had predicted was that for transit providers, rather than charging content providers for transit, that you would be peering with them or some type of a peering arrangement for that large volume of traffic. And so that's really where we kind of took our cue, was, that it wasn't about, this, tier one internet backbone anymore. It was all about being in the IX. It was all about, trying to get more sophisticated on how you could peer with the transit and the transit providers, or the content providers. Our own network, so we're a small company. We're founded in 1911 as a phone company. We're still privately held. We were the first CLEC in Michigan in '96. And then that's our little Euro-style city sticker. Everyone always stops on I-94 because the giant highway sign says Climax. So everyone wants to stop and get their selfie by it. But our silly code is CLMX-MIXI, and that's kind of unique. But when we first joined, we had a couple OC12s. Today, we're peering, about 90% of our traffic, and we've got over 100 gig in upstream ports, so it's really a sea change. But of course, our network now is, all based on ROADM and, gig and 10 gig connections to all the edge carriers. We're also now are acting as a small regional transport provider to a large number of other smaller ISPs. And so we, again, all the data that you're going to see here in just a minute, we're all collected from these automatic generated reports. My colleague, Steve Surdock, has been my partner in helping us move into this Nanolog environment and to understand how to do peering and to make all those things happen. So this is a daily snapshot of all of our upstreams, and then so the graphing you're going to see is all just based on the 95th percentile for each day. And so this is where we've moved to. Right now we're just about ready to break 20 gig. And really, this is a story about Nanog's, the Nanog experience for us. But again, we were really originally pointed this direction by the Internet as Flat paper with the idea that it was all about strategic peering with, with content providers because that's where the traffic is. That's where the bulk of the traffic is. So initially, we just established in Chicago, and then we have presence in Ashburn, and we are just turning up in the 6 Exchange this week, actually. And initially, we were the other big transition for us is we moved from a world of SONET, right, and packet over SONET interfaces rather quickly into carrier Ethernet. And so currently, we've got about 1,000 buildings on fiber and 1,500 miles of backbone, and it's all MEF-based carrier Ethernet. And again, our next iteration will be moving to 10 gig on all those connections at the edge, and we're in the process of doing that right now. And so we initially had gig connections to our to content. Then we transitioned where it was all 10 gigs. And then we did all the basics. And again, this is all from being a part of the Nanolog community, having a lot of people that have helped us and counseled us and given us mentoring. So we joined PeeringDB, and we're in RADB. We're in the various exchanges, and then the ability to make peering contacts. And then as time went on, we started bringing the CDN servers on site. We also host 2 Anycast server instances, and we actually host the Route Views server for Chicago on our cabinet. And then I just threw this in. This is from the Cisco VNI and US Telecom, but it kind of mirrors what we're experiencing, at least. With our own network and our own traffic growth. And so it's just kind of interesting to see, mileage may vary, but I think that the idea was by sharing our data set, it kind of gives the community a sense of what's happening to the internet as a whole, just sort of as a vignette. So as we move to peering, our transit's basically been pretty flat. And it's always been interesting with the transit providers, especially coming to Nanog. It's like, well, transit's only $20 a meg. It's cheap. Why would you want to peer? And then it was, oh, transit's $10 a meg, it's cheap. Why would you peer? And then so forth. And so it's always the same on that side. But we've been able to consistently move, dramatically grow our traffic. And again, it's traffic now directly from the content providers. Mostly what we do see on transit is tier 1 traffic and things like that. And actually our transit would be half of what it was, but one of our major tier 1s has a small content delivery operation. So actually half of our transit is their CDN, which that's another discussion. But there is the path as we had moved, and you can see the most interesting thing here is that the CDN traffic now is between 40 and 50% of all of our traffic. That's just coming right out of our CO. And the rest is all coming off of, the majority of traffic's on P&I at this point. Although we do get significant traffic off of the peering exchanges. But it's sort of an interesting data set. And so we thought we would share it because I think it really tells the story about that the internet becoming flat, where the bulk of the traffic flows now are coming off the IX in terms of the volume of traffic on very short paths, and no longer are transiting the tier 1 backbones per se. Although it does seem like the tier 1 transit is very helpful for bringing DDoS traffic to us. I will add that. So, and then this is the percentages as time has moved on, and you can see clearly as a percentage of our traffic, we went from 100% of our traffic being transit. You can see when we first entered the peering exchanges, and then the big jump is when we started establishing P&Is, and then the green are the CDN. So the CDN is becoming a very important part of our traffic mix. So, and again, in terms of our scale of our network, our K to rank is 1458. We've got 129,000 IPs in our customer cone. We're currently in 3 exchanges, and we're coming along. We've got 246 observed peers at this. This is from the CADA view, and you'll notice the big jump over there in the visible peers, and that's when we join Route Views. And if any of you are not in Route Views, which is a project at University of Oregon, I would highly suggest just dropping a peer connection into them. It's unidirectional. It drops all of your route tables into them, but it is a tremendous tool for us to have visibility into all that. And of course, the key in all of this for us has been the NetFlow tools that we have in-house. And so again, coming to Nanog, this is my 18th Nanog, and it's just been a tremendous experience for us in terms of, we're getting information that we couldn't get anywhere else. And really, it's sort of a master class in internet operation. And obviously establishing IXP present was critically important initially to get market price transit, but then to have access to this revolution that's happened in the past 6 years, the development of all these large content CDNs. And then PeeringDB, we're constantly working. It was very interesting to see some of the automated tools to look for new peers. Although really right now, mostly what we're doing is we're scrubbing transit with our NetFlow tools to look for new peering opportunities. We see something on transit, it's like, well, why is it there? Let's move it into the peer. And again, our like right now, joining the 6, I just took a drive out last week out the Columbia River Gorge, and it was sort of oh, there's a dam, and oh, look, there's a data center next door. It was pretty interesting, and so we feel that having access to 6 will pay off for us in the long term with the astounding number of data centers going in for all the hydropower. And again, I'm so grateful to all the people at Nanog that have been helpful in mentoring us over time. And a big call out to Bill Norton, which we've had initially started getting an education by looking at his Dr. Peering website and some of his material. But he was also just very helpful, just talking to us. And he was interested in what we were doing, so that's been a great relationship. And the other interesting thing is, 52 was the last Nanog that was run by Merit. And so we're sort of, a new NOG member. So, because when we started, Nanog is kind of when Nanog has evolved into this new life that it's developed. And but again, this paper from Amag, with the internet is flat, modeling the transition from transit hierarchy to a peering mesh, it really just was an eye-opener for us, as we were sort of brainwashed that, oh, well, you need transit. And it really helped us fundamentally understand this sea change that was happening. And I just think it's really interesting when you look at the predictions in the paper versus our data set. And of course, it may or may not be true for, all operators, but it really is amazing at how well it foresaw what was going to happen. And again, we view the content providers as really valuable partners. And a lot of them were sort of emerging when we first started this process. But for us, we're trying to offer, a really compelling experience providing, because we moved from dial tone to providing fiber in the last mile and high quality services for our constituency. And so having really awesome, compelling content experiences and services available has made all the difference. I mean, that's what our customers want and desire. So we view that relationship is really critical and important. And plus, by having a lot of the CDN servers on network and the P&Is in place, we're able to offer very high quality services. And plus, it's fun for us. We compete with a lot of larger billion-dollar companies. And so we'll have a small transit, small ISP that'll be hooked up to us into a larger player. And then they'll say, well, why is all the traffic going to you? So, and that's, it's just sort of personal, but we really like it. And so the last piece really is just, this really isn't for everybody. You're going to have enough eyeballs. I've seen some, pretty small companies, oh, we're going to peer. And it's like, well, great, how much traffic have you got? Well, then not much. Well, probably it's not going to work. So you really have to have a certain critical mass eyeballs to have it be worth it to the content providers to work with you. And then the other thing is I'm really grateful. I've got my collaborator, Steve Surdock. It really takes a fair amount of technical expertise and commitment of resources to make peering really work. And then the other part of it is there's a little bit of luck of the draw. It's getting better, but it's just access to transport. The ability to get at waves. We use wave transport extensively. So the ability to get at the IXs, to have diverse paths, at multiple locations, is just vital. And so that really makes a difference. But if you're just a really small provider, I mean, the argument of just by transit because it's easier, it probably is true. And so, like I say, we've been really fortunate through this whole process. I will end with a quick note from, this was at Nanog 68 with Jeff Houston, and he had his desperately seeking default. And in his last slide is, what we have now in 2016 is a tier 1 CDN feeder system. The internet is no longer a true ubiquitous fully connected peer network. And it says, and our collective care factor is pretty low, and that makes me sad, which was pretty dramatic. But I would agree that it's stunning to me to look at, especially having just gone and seen some of the scale of some of these data centers out in the Columbia River Gorge. it's astounding. And again, private, proprietary, no one except them really knows the size and scale of those networks. But I would venture to say it probably dwarfs a lot of the tier one infrastructure at this point, whether you call it a private wide area network or data center interconnect. But it really is an overlay. And I have great respect for Jeff Houston, but I would say the hierarchical system of transit is all still there, and we still get connectivity to pretty much all points, although there's certainly a lot of, as the internet has grown, a lot of poor routing out there. As the more that we learn about it, we're more amazed that the internet works at all. And but this astounding, I think his observation of a tier one CDN system is probably correct, that now there's this massive overlay on top of the legacy backbone that's providing the bulk of the traffic, and I think it's astounding, and our customers are thrilled with the value that it provides to them. So with that, I'm open for any questions. All right. Thanks again. Appreciate it.